class. But if possible, I definitely am not going to take the class today. But the thing is that otherwise I won't be able to complete these things. So that's why I'm taking this class. But please cooperate with me, and I think I'll be able to complete these things. How many of you are here right now? Only 11. Okay, fine. Okay, so I'm starting the session. This session, whenever you face any difficulty for visualizing these things or see these things, please tell me. Uh, so today I'm going to start a new part or new chapter, that is water quality. Uh, Mahatma Gandhi has said that next to air, water is a necessity of life. How much quantity of air we breathe each and every day? Almost 15 meter cube or 15,000 liter per day. And how much of water we used to take? 5 liter of water on an average. If it is 5 liter of water, then it is 3,000 times more amount of air we used to take than the water. So definitely, I mean, survival wise, water, air is more important than water. So air pollution in that respect, if it crosses the threshold limit, then as our intake is more than water, so it creates more problem. Still, both of them are very, very important for our survival. Without air, we cannot live for more than few minutes, but without water, not more than few days. Fine. But the next statement is, therefore, as in the case of air, nature has provided us with ample amount of water, and the drinking water must be pure. Mahatma Gandhi. At his time, the air was pure, more or less, much more pure than this time, and same for water, ample amount of water. Still, we have ample amount of water, but already I have discussed that we are polluting our water. So river water, already I have discussed in bar diagram. The same thing I am going to show you, that this river water is 0.06%. Sorry, 0.006%. So it's very, very less. Huh? We have good amount of groundwater. We are withdrawing it in a unsustainable way. That's why we are facing problem of arsenic, problem of ground depletion, groundwater table depletion, and also the problem of fluoride, etc., etc. On which we depend most, that is river water. This is actually very, very less, and that also we are polluting, discharging the wastewater into it. Especially these developing countries like us, that 70% of our untreated wastewater we are disposing it into the surface water, which is very important to us as a source of water, and which quantity is 0.006%, around 0.006%. And two-thirds of them, or three-fourths of them, I should say, that 75% of that water we are polluting to the disposal of polluted wastewater, untreated wastewater. How we are discharging? To point source. That means through a point we are discharging. And from the area source also, the pollutant from an area to the runoff we are discharging into the surface water. So these are the several point source and non-point source. In this left side, all these are non-point sources, and the right side, all these are point sources. It not necessarily the left side, whatever is there. We have shown like this. These are the area sources and these are the point sources. That means we are disposing the wastewater from a point or a runoff to a runoff from an area. And also we are oil spill etc. also taking place accidentally or sometimes intentionally also in the river. So potable water or drinking water. The potable water or drinking water, potable water means drinking water. It should not be H2O. Apart from H2O, there should be some micronutrients with it. That means it should not be free from or should not be of absolute chemical purity. Some amount of calcium, some amount of magnesium, iron, all these are macronutrients and some micronutrients. Nickel, copper, chloride, not chloride, chloride, sodium, all these things are macro. And some micronutrients will be there. But within very small limits, these things should be there. Then it will be helpful for a healthy water, we can say. And definitely, depending upon the usage, quality of water varies. Whatever water you are using for making hardware or using it in the boiler for generating steam and from it electricity, and whatever water we are drinking and whatever water we are using for our bathing purpose, all quality or irrigation purpose, all quality are different. So depending upon the requirement, quality of water is going to vary. So we have to check the quality. Today our discussion part is the quality. So definitely for that some quality parameters we have to define. So through which we can tell that this water is qualified for this type of usage. Acha. From size wise, we can differentiate, we can distinguish it into, we can separate it out in four categories. If it is more than 10 micron size, normally, though it depends upon the density of that suspended matter or dissolved matter, that if it is more than 10 micron, then we call it is settlable. That means, I mean, within a very less amount of time, this one is going to settle by gravity from the water, separate out from water. I think Professor Somnath Mukherjee has already give you some brief description of these things. And the suspended, if it is in between 1 micron to 10 micron, then it takes actually larger time to settle these things. But yes, you can remove it through the plain sedimentation. Sometimes it is very fine, then you have to add some coagulant to make it faster, so that it forms a larger size, bridging between one particle to another particle, or attracting particles in it or on it, and then it settles quickly. And less than 10 to the power minus 3 micron, that means almost the size of molecules, these are dissolved solids. বাবা ক্লাসে আছি, হ্যাঁ বাবা পরে কথা বলি, এমনি আমরা ঠিক আছি, জ্বর হলেও মোটামুটি ঠিক আছে। হ্যাঁ মা শুয়ে আছে, জ্বর এসছে। তুমি কি বলছো? ঠিক আছে ঠিক আছে, তুমি এখন ডিউটিতে তো? ওকে, আজকে সারা রাত চলবে না ওয়ার্ডে? হ্যাঁ হ্যাঁ, আমি মাঝখানে কথা বলে নেবো পরে। ওকে ওকে বাবা, সরি রে। And in between 1 micron and 10 to the power minus 3 micron, these particles are actually from the colloidal. The colloidal particle, it creates haziness, but thing is that you cannot separate these things with the help of filter paper. Milk, colloidal particles are mixed in it. How to separate this colloidal particle? Adding some coagulant into it, so that all these colloidal particles clog and settles quickly. Otherwise, you cannot separate it out, because these things is going to take almost infinite times to settle, because the particle is so less size, and because of the effect. So this one, কি effect বলে ওগুলোকে? বল। ইন্টারপার্টিকেল, পার্টিকেল গুলো একটার সঙ্গে একটা ধাক্কা খেয়ে এদিক ওদিক এদিক ওদিক মুভ করে। Brownian movement. So because of that, these things are not actually going to settle. So we have to add some coagulant to remove this particulate matter. In normal water, we can neglect these colloidal impurities. We can neglect for the normal water. But if it is there, then definitely you have to add this coagulant. Otherwise, for the suspended particulate matter, if we want to remove it much faster rate, because we need it, then we have to add some coagulant into it in the form of alum, in the form of ferric sulfate, in the form of different ferrous sulfate also. So all these things are going to act as a Now the meteorological water. What is meteorological water? We talked about rainfall and also the hydrological cycle. So we know these things. This is very common to you. Now we have to think about to utilize this water, because this is the source of all water, and lots of water is actually goes out. Already I have discussed. So what is the characteristics of this water, quality of this water? Initially, that's why we have to first flush, we have to do that first 5 minutes or 10 minutes of water, we have to discard these things because of the presence of this dust, shoots, and also microbes, and also gases, dissolved gases like SO2 in the forms H2SO4 or NOx, etc., which creates acidity. And definitely after filtering these things, before utilizing these things for drinking water, we have to disinfect with the help of chlorine. In many places, it depends only on the rainwater, direct rainwater. Maldives, one example. More than 90% of their water, source of water, is actually the rainfall, direct rainfall. They catch it, use it. Darjeeling area, Jalapahar. In the Jalapahar, they used to catch these things. The topography is such that there is a water, this rainwater reservoir is there, and then from there, this is the, I mean, the higher elevation than the Darjeeling area. So from that, by gravity, you can supply this. And another is surface water. In the contrary, the surface water is actually the lakes, ponds, etc. The surface water has some more pollutants present in it, because as it is a runoff water basically, for the rain, for the because of the rainfall which actually passes to the surface. One portion is percolate through it, one portion is passes to the surface, and as because it passes to the surface and lots of pollutant present in it, that's why this one is a having some pollutants present in it. Say if it is passes to the marshy land, swamps, then definitely the organic matter is going to present in it. It should be colored, because organic matter creates color. And if it is turbidity, etc., then it passes to the clay soil, then it will be highly turbid. Or if it is sandy soil, also, if sand is fine, then also it creates turbidity. That's why in the rainy season, you will find that the river water is much more turbid than the winter season. If it is passes to the cultivated land, then definitely in the cultivated land, we have applied the fertilizer, we have applied the pesticides, the herbicides. So all these things will present. And also in the cultivated land, the bacteria will be there. So presence of bacterial contaminations will be high. So these are the characteristics of surface water. But not much minerals are present in that. But if it is groundwater, then because of the filtering action of the top layer of the ground, then turbidity will be less. Presence of bacteria, presence of suspended particulate matter will be less, because these things, this layer, top layer of the soil, before aquifer, top of the aquifer, any aquifer, this one is going to act as a filter. So it's clear water, apparently. But as it passes through the different strata of the soil, depending upon the nature of the soil, the quality of the groundwater is going to vary. So dissolved chemical is going to be more. So if it is passes through the limestone formations, then hardness will be more. That means different presence of different chemicals, calcium, magnesium, along with sulfate, chloride, nitrate. These things will be more. So it will be the, because depending upon the nature of these things, it will be more. And you know that whenever hardness will be more, it will be depositive in nature. That means it creates forms, it creates scale formation, or it forms scale. So these things, if it is more than the its solubility, then it's deposited. It is not corrosive, depositive in nature. But thing is that it creates scale. So what is the effects of scale formation? You know, later on I'll discuss. But thing is, because of that, the carrying capacity of the pipe is going to decrease, or the thermal uh, exchange capacity of the pipe is going to less, or going to deteriorate, and then cracks are going to develop in the pipe in this case. On the contrary, if it is passes to the ignite formation of this rock, then it will be soft water. Not much calcium, magnesium will be there. Then it will be low in dissolved solids, dissolved minerals, but as it passes to the first initial layer of the soil and the air, in the soil also the bacteria is there, they emit carbon dioxide, so it absorbs carbon dioxide, and as the amount of CO2 is more, that means it will be carbonic acid is going to form, that means H2CO3 is going to form. It will be little bit acidic in nature, as it is acidic in nature, so it will be corrosive in nature. If it is iron pipe, it passes through iron pipe, then definitely some amount of irons are going to dissolve slowly into it. So that's why always we try that it should be not very much depositive in nature, but slightly depositive in nature, so that it should not corrode the pipe. Because some amount of calcium, magnesium, these are macronutrients, these are helpful for us. This is healthy for us. But whenever this amount is going to be more, so because of scale formation, because of depositive in nature, high deposition, etc., these things are going to create problem. Otherwise, small amount is good. Now, for the potable water, what is wholesomeness and what is palatability? Wholesomeness means it should be safe water. That means it should be uncontaminated by the bacteria and also free from poisonous substance. That means not much of lead will be there. Hmm. Not much of copper will be there. Not much of arsenic will be there. It should be more than the permissible limit. Poisonous substances will be less. And the excessive amount of mineral or organic matter should not be there. Free from excessive amount of water. That means it should be safe water. And another water, palatability is an aesthetic sense of water. That means you're looking for color. It should not be color. There should not be any color. Okay, don't we drink colored water? Yes, tea or Coca-Cola or some other Mirinda or some drinks. We know the source of this color. We know these are not toxic. But if it
Sir,
is
so we don't can't call Coca-Cola as a palatable water.
uh, actually there is some controversy also. We cannot say that this is not a palatability of, I mean, palatable water. Water-wise, cannot say palatable, but as we know the source of this color, then we drink. I want to say that means colored water doesn't always means it is a toxic water. But whenever this is not going to meet the palatability quality of the water, definitely, definitely. But but I wanted to say that colored water doesn't always signify that that water is toxic. Though there is some controversy that what I am saying that drinking of Coca-Cola is good. No, it is not always good. Health-wise also, this is not good. I mean, if you drink it more than a certain limit per day, regular basis, if we drink it, then it's going to create enormous pressure our kidneys, so our kidney is going to create problem. So I'm not going to that aspects. Normally we drink color water, we can drink to tea. If it is a green tea, then this is also light brown color, we can take it, but this is not palatable quality, non palatable quality. If it is palatable quality, then free from color, free from turbidity, there will not be any haziness, and definitely there should not be any taste and odor, and of moderate temperature. Why I'm saying this is an aesthetic sense? Because if you look at this, that color, turbidity, taste, odor, and the moderate temperature, sometimes we drink along with all this quality, all these parameters. But knowing the source of all these things, T, its temperature, it's a more than the moderate temperature. It has some odor, Darjeeling tea. Definitely, it has taste, turbidity. All these things are not crystal clear. If it is allow milk in it, then definitely it's turbid water because of colloidal substances, and it's colored also. But that's why I'm saying this is not the part of the wholesomeness. Wholesomeness means safe water, and this one is the aesthetic sense. If I can say that palatability of water. Huh? But your question is right. Whether the Coca-Cola is palatable, can we consider this is a palatable water? The answer is very straightforward. No.
Okay, sir.
Hmm. So these are the characteristics of water. So how we are going to define this water is going to meet these standards? These are the some of them are physical characteristics, some of these are chemical characteristics, and some of them are bacteriological characteristics or bacterial characteristics. Hmm? Okay. Try to understand these things, what I'm saying. So these are not the all. Later on, I'm going to discuss these things in detail. The what are the different parameters of water? But okay, these are some parameters we can differentiate from physical, differentiate it in the physical, chemical, and bacteriological characteristics. Then, how we are going to define these things? So, which one is, I mean, more dangerous? Which one is less dangerous? That means whenever limit, so we have to define certain limit. Hmm? So look at this. So method of risk assessment. We have to go for the method of the risk assessment. Then it can be the catastrophic to insignificant, depending upon the its presence. Huh? So look at that last row. The risk rating, if it is the score is less than 6, then low, then medium, then high. If it is more than 15, it is very high. Then presence of this material or pollutants, whether this one is, these are the score. If it is almost certain, but insignificant amount is going to present, it is 5. But it is almost certain and its toxicity is very, I mean, uh, high, then it is catastrophic. The That means this is catastrophic. 25 is the score. Likely. That means not almost certain, but sometimes it's going to present. Many a times it not be going to present. Like moderately likely, like unlikely, like rare. It's going to that it is very toxic, but rare these things are going to present. Then score is 5. And the last one, the catastrophic and the rare, is 5. So in that way we can find the severity of consequences, the method of risk assessment. So in that way, we can tell this one is which parameter is qualify the particular quality. These are once per day and once in every 5 years. This is the rare, and once per day. This is the almost certain, and in between values are there. This is the likelihood. That means its presence of this pollutant. And another one, this is the health impact, public health impact, no impact or not detectable at all, or moderate. This is only aesthetic impact. and regularity impact and compliance impact, like that. This is minor. So in that way we can find out. This is one way. Another way, there's you have to find some dose, tolerable daily intake. You have to find, that means how much you can, after taking these things, you shouldn't have appreciable health risk throughout your lifetime. Hmm? In that means it should not be LD50 or like that. LD50 means lethal dose 50%. L, capital D, in the subscript it is written 50. That means if you take that particular dose per day, milligram, as a milligram per liter of your body weight, or milligram per kg of your body weight, but not per liter, milligram per kg of your body weight, then after 14 days 50% of us is, if it is going to, definitely it should not be tested on us, it should tested on mice, rats, guinea pigs, etc. And then if the 50% of them are going to die, and then it is called the lethal dose, lethal concentration, if it is water, if it is liquid. Hmm. If it is air, this is threshold limit value. That means 8 hours per day, if you are present in that higher concentration, then you return to your good ambient, then it is not going to cause any irreversible damage to your health. So in that way, we used to find out, as this is not the air, so it's a tolerable daily intake or acceptable daily intake for food and for food additives and pesticides. You have to measure these things. And then definitely no observed adverse effect level, like that, lowest observed effect level. You have to find like that. Then you have to consider the uncertainty factor, that means variation of the source, variation of the specimen, that means how much these things, particular arsenic, we can how much we can withstand, how much the the USA people or the Ugandan people, they can take that things. This is also going to, this is the uncertainty. Corona, definitely compared to us, percentage death in India is less compared to USA. Compared to the high class society people, much lesser death in the slum dwellers. So these are the uncertainty. Still, we have to fix certain limit, considering all this uncertainty. Then I'm not saying that you have to know these methods on all these things. Then the guideline value we have to find out, the TDL to TDI, that means total daily intake, multiplied by BW, that means your body weight, definitely, into P. P is the fraction of the TDI allocated to drinking water. Huh? How much fraction of the total daily intake is allocated to drinking water? Then the daily water, see the daily water consumptions. In that way, you have to find out the guideline value. So, why I'm saying all these things, there are certain methods through which we can say that this quantity, ওই আকাশ থেকে টপকে পড়েনি এটা, this quantity we have defined, this value is tolerable for us. Hmm? That wise, that way, this is tolerable for plant, that's why we have considered, that's why this is going to vary from irrigation to drinking water. The quality parameter, salinity, vary from drinking purpose to the irrigation purpose. In the drinking purpose, sometimes you can allow, I mean, the worst cases, 1000 milligram per liter, but for irrigation purpose, 500 milligram per liter. Hmm? But other parameters we can allow more, BOD we can allow more, some nutrients we can allow more, but for us we cannot allow more than that. So they can withstand, we cannot withstand. So there is some processes are there to finding out the risk assessment. So through this assessment, we have to find out. Then these are the things. I'm not going to go through this detail. LD50, LC50. This definitely. Which one will be more toxic? Say something. If you take 1 gram of your body weight, you are then the 50% of our state specimen is going to die. Another thing, if you take 2 gram uh, per kg of body weight, then 50% of the state specimen are going to die. Which one is more toxic? First one or second one? If you take 1 gram, then you are going to die. If you take 2 gram, then you are going to die. Which one is more toxic?
1 gram.
1 gram. So apparently value of 1 gram is less than the value of 2 gram. So that's why it is 1 by toxicity potential. And this one is very simple way of defining this thing. Toxicity potential is defined as 1 by LD50 like that. So many other things are also you have to consider, because it is not only the direct hazard value, also you have to consider the BOD half-life value. Say for example, the if it is uh, uh, say glucose, then this is readily very quickly this one is biodegraded, it will biodegrade. But if it is it's a pesticide or herbicide like DDT, if it is then maybe for 100 years, maybe for 50 years it will be there. So say for example cyanide is very toxic, but this one is going to dissociate, going to disappear from the uh, I mean the water much faster than the uh, DDT. So its beauty half life or hydrolysis half life is less. Though it is more toxic, same amount is more toxic, but as it is not going to stay for the longer period of time, 100 years period of time or 50 years period of time, so it is not going to get chance to create that its toxic effect, to spread its toxic effect for during the prolonged period of time. And also the bioconcentration, if you take certain amount of arsenic, certain amount of cyanide, it is going to go out of our body. It is, though it is toxic, but maybe instantaneously arsenic or mercury, it's not so toxic. But thing is that this one is going to bioaccumulate into our body. So this one is going to transform from one species, from lower species to higher species to the food chain and accumulate in our body. And then whenever it crosses limit, is manifest as a Minamata disease for mercury, melanosis, keratosis, hyperkeratosis, skin cancer, amputation of our body, if it is arsenic. So different way, there is a different way. My intention is to say all these things. There is a different way for calculating this risk. So on the basis of risk, so we measure these things. This 10 hour drinking water specification standard is IS 10500 2012. Why 2012? In the 2012 is the latest one, though it is not the latest one, because so this is another thing I should say, that nothing is fixed at present moment. At 2012, whatever knowledge we had during that period, best knowledge we had, on the basis of that we decided that this is the limit. Later on, something we may relax, something we may go for the stringent limit because of the upgraded knowledge. So it may change. So the last one is at 2012 10500. So 10500, this is the highest code number, and 2012 indicates then on which year this one is actually marked as the limit. So there is a earlier there is only two tables. One is the different parameters, and another parameters is the biological or bacteriological quality parameters. Right now we have divided into six numbers of tables, like, and we have followed the European Union directives, EPS standards, WHO standards, and also our earlier standards developed by CPHEEO manual that is present in the manual of water supply and treatment 1999. So these are the parameters: organoleptic and physical parameters, general parameters concerning substances undesirable in excessive amounts. Then third table is the parameters concerning toxic substances. Then the separate parameter table, parameters concerning radioactive substances. Then pesticides, there is a separate table for pesticides. And then the last table is the bacteriological quality of the drinking water. These are the six stabilities, all these parameters. This is drinking water standards. This is divided into six tables. And these characteristics are defined by the name of these tables. So from the name of these tables, you can identify what will be the nature of these parameters of these tables. Look at, these are the organoleptic or physical parameters: color, odor, uh, pH value, taste, turbidity, and the total dissolved solids. These are the parameters for our first table, organoleptic or the physical parameters. Uh, you better for these things follow the book of S.K. Garg, because this is the Indian standard book. Because I mean, very difficult for me to go for the detailed discussion of the Hazen unit, what is the Hazen unit, and all these things, because all these units are very important. In your GATE exams, this one is going to come. What is Hazen unit? And what is the int? What does it mean by NT unit? How the NTU is measured? Huh? What is the basic principle of measuring NTU, nephelometric turbidity unit? What is its difference between the Jackson turbidity unit to nephelometric turbidity unit? What is the standard used in the NTU? All these are very, very important. But here it is very difficult for me. Whatever possible, I will discuss. But please, you go through the, because this is the Indian thing. So Indian standard books, you are going to get these things. So S.K. Garg in that respect is a very good book. Maybe some other books are also there, but as I have gone through that books, so I can tell that name of this. Look at that. The second column, actually, the serial number characteristics. Characteristics means these are the parameters. And then the third column is the requirement or acceptable limit, or you can say these are the desirable limit. If it is this, if it is, it should be in this limit. Color should not be more than 5 Hazen unit. Color should not be more than 5 Hazen unit. Or turbidity should not be more than 1 NTU. Or total dissolved solid should not be more than 1 NTU. But if there is no other sources in your vicinity, in your nearby area, then you have to, it can be relaxed up to, see, that's why this is the permissible limit, not a desirable or acceptable limit. Maximum, it can go up to the permissible limit in absence of alternate source. Color 15. Odor is same. For pH value, there is no relaxation. Not necessarily that it should be relaxed. Turbidity, it relaxed to 5. Earlier, it was 10 and 50. 10 and 25. Now, it becomes much more stringent. 1 and 5. So it is going to change time to time. And then dissolved solids, 500 and 2000s, like this. And remarks column, you also go through this thing because these are also important. Look at that for color. Extend to 15 only if toxic substances are not suspected in absence of alternate source. That means if you think that okay, any type of permissible limit up to for color for 15, it is allowable. No, we have to ensure that whatever color is actually we are getting this color in that this is not for toxic substances. Then and only then we can go up to 15. Otherwise, not. So I'm not going to go through these things in very details. So these are the general parameters concerning substance. So look at that. These are aluminium, ammonia, that anionic detergents, barium, boron, calcium, chloride. Look at that, 250 and 1000. Copper, fluoride, 1 and 1.5. Free residual chlorine, it should be desirable zero point 0.1, but sometimes it can be more than zero point 0.2, can be 1 also. Sometimes we have to go for that because of the epidemic for killing all these bacteria, viruses, and all this making inactive to the bacteria, viruses. You know how can inactive bacteria, virus is not at all a living thing. Still, it creates problem. So making it inactive, making to break that its outer shell and all this, making it inactive. So sometimes we have to go for the higher dose of chlorine. Hmm. Now, now look at that. This one for iron. Look at that iron in this 10500 2012. This is the amendment at 1st June 2015. So it was decided that that it substitute 1. Earlier we can go up to substitute 1 for zero point 0.3. Whatever zero point 0.3 is there, we can utilize now 1. Iron amount is 1. Not necessarily the value is going to reduce. The value is going to be more also. And it is also related to iron and manganese. Iron and manganese. That acceptable to be acceptable. So right now we have relaxed it. At present, this is relaxed value is 1, not 0.3. So, and there's no relaxation. That means for permissible limit, it is also 1. But to be acceptable only when water is chlorinated and tested at, this is for free residual chlorine. And for iron, this one is total concentration of manganese and iron should not be more than zero point 0.3 milligram per liter. Only iron you can consider this one, but total concentration of iron and manganese should not be more than zero point 0.3. That means there should not be more manganese concentration. Then and only then it is acceptable. And this is also if it is chlorinated, and then when the protection against a viral infection, which I have told, and it should be minimum zero point 0.5 milligram per liter. Not, it can go up to 1 in certain cases. Same, that's manganese. Magnesium, manganese, zero point 0.1, maximum 0.3. So these are the things. Zinc, 5, 15. So if you look at this from the from the next table, you will find these amounts are may present much more than the next table. because these things are not so toxic as the parameters present in the next table, table number 3. Hmm. For phenolic compounds, definitely this is toxic, but nitrate 45, but no relaxation. Mineral oil like this, zinc 5 and 15. Total hardness 200, it should be 200 desirable or acceptable limit is 200, but in absence of this any other source that it can go up to 600, 600 as CuCO3. Now, look at this. These are the toxic substances. If you look at the values of these parameters, then from that you'll be able to understand. So, for example, mercury 0.001 and no relaxation. Cadmium, though we need some cadmium, need some lead, but it should be very, very less. That's why all these are micronutrients, not like ক্যালসিয়াম কোথায় হলো ক্যালসিয়াম আগে আছে বোধহয় হ্যাঁ ক্যালসিয়াম লাইক 75 200 chloride the value is 250 this one is 0.01 lead mercury is highly toxic 0.001 and arsenic earlier one the iron I have shown you it has relaxed from zero point 0.3 to 1 now look at that arsenic acceptable limit or desirable limit was zero point 0.01 milligram per liter or zero point 0.01 ppm or 10 ppb parts per billion. And the relaxed, it was relaxed at a 0.05. But in 2015, there is, it should be no relaxation instead of 0.05. That means now the arsenic limit is 0.01, not up to 0.05. But because I have seen you, if it is 10 ppb also, then also out of 100 population, maybe 1% may have cancer. 1% may get cancer out of it. That's why it is reduced, and I'm sure in the within the next few years, it is going to reduce to 5 ppb, not 10 ppb. That means it is not. It will be reduced to not zero point 0.01. It will be 0.005. As reducing that amount is very difficult up to that reaching the up to that level it's very difficult, that's why they have relaxed it. It says it is very costly to reaching that level, that's why it is relaxed up to this. Later on, if the technology is going to come in a very cost effective manner, it will reduce, because we cannot take the risk that it is a maximum limit that up to one person is going to die because of this presence of this arsenic within the permissible limit. 20% of the population of the Bangladesh are dying because of the presence of arsenic in the water. Now the radiological aspects, radiological parameters. This is alpha particle and beta particle, alpha emitters and beta emitters. তোরা এটা আমার থেকে ভালো জানিস, আলফা এমিটার কি বলতো? এনি ওয়ান অফ ইউ? আমি একটু হিন্টস দিচ্ছি। হিলিয়াম, বল হিলিয়ামে কটা থাকে?
ওই হিলিয়াম থেকে হাইড্রোজেন হলে একটা ওই আলফা পার্টিকেল বেরোয়, মানে হিলিয়াম থেকে দুটো হাইড্রোজেন হয়ে যায়, একটা আলফা পার্টিকেল এক্সেস থাকে।
একটা আলফা পার্টিকেল এক্সেস থেকে দুটো হাইড্রোজেন বেরোয়। হিলিয়ামের এটা বল, স্ট্রাকচারটা কত, কি হিলিয়ামে কি থাকে বল।
দুটো প্রোটন, চারটে নিউট্রন।
শিওর? কেউ একজন এটা খুঁজে দেখ, কটা প্রোটন কটা নিউট্রন। দুটো প্রোটন দুটো নিউট্রন, তাহলে ইলেকট্রন কটা আছে? দুটো। দুটো ইলেকট্রন বেরিয়ে যাওয়ার পর যেটা পড়ে থাকে, দ্যাট ইজ অ্যাকচুয়ালি আলফা পার্টিকেল। দেখ আমি ঠিক বললাম কিনা।
হ্যাঁ হ্যাঁ হ্যাঁ, তো ওটা ভর সংখ্যা, মানে 2He4 লেখা হতো। হ্যাঁ, 2He4। হ্যাঁ, 4 মানে ওই নিউটনটা দুটো আছে। হ্যাঁ ঠিক আছে।
হ্যাঁ, তাহলে তুই যেটা বলছিস তাতে তাতে 6 হয়ে যায়, তাই না?
হ্যাঁ হ্যাঁ হ্যাঁ, 6 হয়ে গেল।
হ্যাঁ। তাহলে আলফা পার্টিকেল, this is also, and another one is beta emitters. Beta কি? ইলেকট্রন বেসিক্যালি।
হ্যাঁ,
নাকি?
-1 বিটা 0 দিয়ে বলা।
হ্যাঁ, ফাইন। তাহলে these are the, তাহলে যে ধরনের radioactive element which the things emitting the alpha particles or beta particles, 1 becquerel per liter, that means 1 disintegration per second. That means 1 disintegration of alpha particle, 1 emission of alpha particle per second. This is the becquerel. এটার হায়ার হচ্ছে কুড়ি, মাদাম কুড়ির নাম শুনেছিস, মাদাম কুড়ি, পিয়ের কুড়ি, ওর মেয়ে আছে সবাই। So in the present, in the, so now this one is the actually the practical limit they have decided, becquerel, 1 integration per second. Like beta emitters is 1 integration per second. As the penetration power of alpha particle, that means toxicity is more, 10 times more, sometimes 10 to 20 times, say consider 10 times more. It's, that's why it is considered as 0.1 alpha particle, and beta emitters, this one is 1, that means 10 times more is allowable, and this no relaxation. So this is the radioactive parameters, radioactive substances. Now all these are pesticides. It's only one limit. These are the limit. Many of them say atrazine. These are the herbicides. Huh? DDT, look at this. 1. Sometimes someone is 30. Some delta is C is 0.04. This indicates its toxicity. Malathion, this one is 190, but this one may not be, I mean, the very toxic to this one is a herbicides or pesticide. This one is may not be very toxic to cow or something else, but this one is very toxic to human, because it creates a huge problem to human nervous system. আগেকার দিনে কনসেন্ট্রেশন ক্যাম্পে দিস থিংস আর ওয়াইডলি ইউজড। মানুষকে মানে নার্ভ গুলোকে ব্রেক করে দেওয়া, মানুষকে মেরে ফেলার জন্য ইটস ওয়াইডলি ইউজড ইন দ্য কনসেন্ট্রেশন ক্যাম্প ইন দ্য সেকেন্ড ওয়ার্ল্ড ওয়ার। সো অল দিস,
স্যার, টক্সিসিটি আর কন্টামিনেশন এর তফাৎ বলতে গেলে, ওটা কন্টামিনেশনটা কি অর্গানিক কোনো ম্যাটারের জন্য হচ্ছে বলে সেটাকে কন্টামিনেশন বলবো, আর টক্সিসিটি কোনো রেডিও অ্যাক্টিভ দিয়ে পলিউটেড হলে টক্সিসিটি বলবো?
না 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 না, টক্সিক মিন তোর ইউজের উপরে তো কাজে, একটা একটা কোনো একটা জিনিস এটা গাছের উপরে কত টক্সিক, তার মানে গাছ কতটা উইথস্ট্যান্ড করতে পারে আর তুই কতটা উইথস্ট্যান্ড করতে পারিস। ইফ ইউ ইউজ ইট অ্যাজ এ ড্রিঙ্কিং ওয়াটার সোর্স, তুই যদি গায়ে স্নান করিস তাহলে একরকম, তাহলে আর্সেনিক কনসেন্ট্রেশন ক্যান বি মোর দ্যান দ্যাট, কারণ ওটার মধ্যে থেকে ভেরি স্মল অ্যামাউন্ট মেবি তোর পেটে যাচ্ছে, মেবি তোর গা হয়ে ভিতরে অ্যাবজর্ব হচ্ছে, আদারওয়াইজ মোস্ট অফ দ্য থিংস ইজ গোয়িং টু গো আউট। তাহলে একটা কনসেন্ট্রেশন বেশি হতে পারে, তাহলে আমার সেইভাবে আমি
ডিপেন্ডিং আপন দ্য ইউজ।
একদম ডিপেন্ডিং আপন দ্য ইউজ, কতটা তুই ইউজ করতে পারিস, বললাম কতটা অ্যামাউন্ট তোর বডি নিতে হবে। টোটাল ডেইলি ইনটেক মিনস ইফ ইউ গোয়িং টু টেক দিস থিংস এট ডেইলি ডোজ, ডেইলি ইনটেক যদি ওই দ্যাট মাচ অফ অ্যামাউন্ট ইউ আর গোয়িং টু টেক উইদাউট এনি substantial amount of damage, that means without any irreversible damage, then it is fine. Otherwise it's toxic. Toxic means এটা, এবার টক্সিসিটি কিভাবে আসবে না আসবে দ্যাটস ডিফারেন্ট। তোর গায়ে ক্যান্সার হয়ে তার হাত কাটা কেটেও তো টক্সিসিটি আসতে পারে, তোর লিভার পচে মরে গিয়েও তো সেটা টক্সিসিটি আসতে পারে, কারো লাং বসে গিয়েও টক্সিসিটি আসতে পারে, কারো নার্ভাস সিস্টেম ব্রেকডাউন হয়ে গিয়ে তার টক্সিসিটি। এক এক জিনিসের উপর এক একভাবে অ্যাক্ট করে। হাউ ক্যান ইউ ডিফাইন দিস থিংস? I mean, how can you define these things? মানে toxicity is toxicity. Toxicity overweight. Toxicity মানে how much how much we can withstand. Cyanide. Cyanide নিলে পরে তুই ব্লাডের মধ্যে থেকে আর ব্লাড তোর অক্সিজেন নিতে পারবে না। তার কারণ ওই কার্বন মনোক্সাইডের মতন পুরো জিনিসটাই থেকেই ওই হিমোগ্লোবিন সঙ্গে সঙ্গে ওর সঙ্গে অ্যাটাচড হয়ে গিয়ে ও আর এর থেকে অক্সিজেন নিতে দম বন্ধ হয়ে মারা যাবে। কেউ দেখায় না যে সায়ানাইড নিল আর টক করে ঘাড় কাত হয়ে মরে গেল, একদম না। তুই দম বন্ধে মারা যাবি, মিনিট 4-5 লাগবে তোকে দম বন্ধে, অত সহজে মরে না, খুব কষ্টের। সেজন্য তো টক্সিসিটি বলতে গিয়ে বললাম অনেক রকমের টক্সিসিটি মিলে একটা টক্সিসিটি। ডাইরেক্ট ডোজ মিলে যে হার্ম করছে সেটা শুধু তাই নয়, আর্সেনিক হয়তো অত হার্ম করছে না, বাট ইউ আর টেকিং দ্যাট অ্যামাউন্ট অফ আর্সেনিক স্লোলি ইট ইজ অ্যাকুমুলেটিং ইন ইউর বডি। 10 বছর পরে গিয়ে তার ম্যানিফেস্টেশন শুরু হলো। ইট ইজ কালারলেস, ওডারলেস, হ্যাঁ, টেস্টলেস, তুই কোনো বুঝতেই পারবি না যে তুই আর্সেনিক নিচ্ছিস। নেপোলিয়ানকে তো ওইভাবেই মেরেছিল। আর কত লোক কিভাবে মারা গেছে এভাবে ইন্ডিয়াতে। লাল বাহাদুর শাস্ত্রী কিভাবে মারা গেছে কে জানে। এটা হচ্ছে ব্যাকটেরিওলজিক্যাল কোয়ালিটি অফ ড্রিঙ্কিং ওয়াটার। আমি কলিফর্ম গুলো নিয়ে বলবো তোদের। আমরা কলিফর্ম দিয়ে এটাকে ডিনোট করি, কলিফর্ম ব্যাকটেরিয়া। Again, I'm saying most of the coliform bacteria, more than 99% of the coliform bacteria are not pathogenic bacteria, non-pathogenic bacteria. But this one is a very good indicator of the pathogenic bacteria. If pathogenic bacteria is present, then there is a chances of presence of pathogenic bacteria is more. So that's why with the help of coliform bacteria, এটা দুটো ভাগে ভাগ করা হয়, সেটা আমি পরে বলছি। কলিফর্ম ব্যাকটেরিয়া, থ্রু দিস কলিফর্ম ব্যাকটেরিয়া উই টেস্ট ইট। দেখ সবকটাই কিন্তু দেওয়া আছে, শ্যাল নট বি ডিটেক্টেড এনি 100 ml অফ স্যাম্পল। কি কিভাবে দেওয়া আছে? অল ওয়াটার ইন্টেন্ডেড ফর ড্রিঙ্কিং শুড নট, কলিফর্ম ব্যাকটেরিয়া শুড নট বি ডিটেক্টেড ইন এনি 100 ml of sample. Treated water entering in the distribution, which after treatment entering into this distribution system, no coliform should be present. And in the consumer, treated water in the distribution system, and when it reaches to the consumer, then also they should not be present in 100 ml of sample. এইভাবে দিল কেন বলতো আলাদা আলাদা করে? তুই এখানে যখন treated amount of water in the distribution entering in the distribution system, what is the difference? তাহলে এইখানে পাইপের মধ্যে আছে, তার সঙ্গে কি ডিফারেন্স পড়লো যে এটাকে আলাদা করে আবার মেজার করতে হলো? হোয়াট ইজ দ্য ডিফারেন্স বিটুইন দিস টু? আমার তো মাঝে মাঝে ইচ্ছা করে কোশ্চেনগুলো এইভাবে দিতে, বলে যাই কেন এটা হলো, কেন দরকার বলো? আরে যেটা ঢুকছে সেটাই তো বেরোচ্ছে।
স্যার কিন্তু মাল্টিপল করতে পারে তো এখানে থাকাকালীন।
কেন মাল্টিপল করবো না? কি ছিলই না তো মাল্টিপল করবে কি করে? শুড নট বি ডিটেক্টেড, নাথিং ইজ দেয়ার, হাউ ইটস গোয়িং টু মাল্টিপ্লাই?
মানে যত কোন কোন লিকেজের কারণে ওখানে ঢুকে যেতে পারে।
লিকেজের কারণে ইন্টারমিটেন্ট সাপ্লাই। সো যে সময় পাইপে কোনো প্রেসার ছিল না, জল ছিল না, তখন ওখানে ওয়াটার বডি ছিল, সয়েল ছিল, লিকেজ দিয়ে দ্যাট মে এন্টার ইনটু ইট। সেই জন্যই তো আমি ক্লোরিন বেশি করে দেই, so that throughout that period some amount of chlorine should present there to kill all those bacteria which is going to enter through these pores, all this leakage. তুমি কখনো কোন সিস্টেমকে লিক প্রুফ করতে পারো না। You cannot tell that this is leak proof, then it will be extremely costly. কারণ তুমি 30, you are designing for 30 years, maybe for the first 10 or 5 years it will be leak proof, then maybe after that it will be, there will be some leakage. তোমাকে সেইভাবে তো সিস্টেম ডিজাইন করতে হবে, সেইভাবে you have to design these parameters. These are another class of differentiating the water quality. If it is drinking water, তুমি যখন কোনো একটা সোর্স নিচ্ছ, এক মিনিট আসছি, দাঁড়া। This one is the designated best use of water. That means from the source, if it is water is like this, then we can utilize this for these purposes, designated best use for drinking water source without any conventional treatment. But after disinfection, we can use if these are the parameter. That means total coliform shall be 50 or less in 100 ml. To the MPN technique, most probable number technique. pH will be within this range. Dissolved oxygen should be at this. And BOD value should be 2 milligram per liter or less. Then after without conventional treatment, but after disinfection, we can utilize these things. Then this one is the presence of these things more relaxed. Look at these values. More relaxed. Then you can utilize for outdoor bathing. But drinking water source, if it is more toxic, like C, coliform bacteria, this total coliform bacteria, instead of 50, instead of 500, if it is 5,000. And these are the pH and dissolved oxygen, 4, not 6. And the BOD value is 3. Then after this source, after conventional treatment and disinfection, that we can see. This is the class C of water. That means this is the quality of the source of water. Class C water means it is under this category, so you have to treat it and drink it. And the propagation of wildlife at fisheries, look at that. No point for, no parameter for coliform organisms. But dissolved oxygen is good. It should be 4. It is not less, 4. Free ammonia, new thing has given. And the BOD value is 2, then this one. And the irrigation purpose, pH value is same as earlier. Conductivity, 2250. There's some dissolved solution should not be more than that. Sodium absorption ratio, that means all these boron. That means these are related to the irrigation. That's why this is the depending upon the usage, we have to select. This is the source-wise category. Source-wise, this is the class A to E. Then below E is not meeting any standards. This is the CPCB, Central Pollution Control Board's guideline. So these are for the sources. If these are the criteria, then this will be the usage. Then definitely for C class, after this conventional treatment and disinfection, it should meet 10500-2015. Now, one after another, and very and quickly, I'm going to cover these things. All these parameters, what I am going to discuss based on 2012. That 10500-2012. Look at these sources. Look at this. Why we are saying this color as a unit. These are the sources are tannin, iron, copper, manganese, and some natural deposits. These are the sources. And the treatments are given. I'm not going to the treatment part. That will be discussed by Professor Somnath Mukherjee. Oh, this one is a clear one is clear water, crystal clear. Another one is a colored water. Color, water of the the color of the water is actually not pure. Its water is not a pure colorless. It's a very actually turquoise blue. Turquoise blue. That means if it's a huge quantity of water is there, this from the sea. Look at this color is turquoise blue. So and so there is some color. This is a natural color of water. That its frequency spectra shows that this is a very light shade of turquoise blue. So when the huge amount of water is present, then it shows. And also this color sometimes comes because of the presence of minerals also, but this pure water is also shows the turquoise blue spectra. I have said the Hazen unit. Hazen unit. Sometimes the floating particles, that algae, etc., these are also sometimes create color in the sea. Acha. Look at that. This color. One is apparent color, another one is true color. What is apparent color? The color of the whole sample. That means both how the color is imparted, the presence of dissolved and suspended solids. Now, if you so presence of suspended solids, if you pass through the filter paper, then definitely the suspended solids is going to remove. Then whatever the remaining color, that one is the true color. That means true color is due only due to the dissolved compounds. আমি যেটা আগেই বললাম that color money is not potable. You can drink it because if you know the source. So for example, tannin, if it is there, then definitely you can drink it. Sometimes have inorganic compound, not only that always organic material. Sometimes inorganic compound like iron and manganese also impart color. This is the removal technologies. I'm not going to filter, etc., etc. Look at this color of this tube. This is the Hazen unit. In the Hazen unit, the color is the straw color. In the note, this one is given. This is a potassium tauroplatinate. This is a mixture of potassium tauroplatinate and crystallized cobaltous chloride. This much amount and this much amount. The amount is given in 100 liter of water. Then it creates 1 liter of 100 ml concentration. Then it create, and then if you make it 1 liter of solution, then whatever color is going to develop, it has a 500 Hazen unit. And this is the Nestler tube. This long tube. The long tube, in the different dilution, you mix it, and then from top of that, you look at this one, and then you, by the comparison with this with your eye, you can say that this color is more or less near to this. Say one is 5 and another is 10. By comparison, visual comparison, you can say this is okay. This one is in between 5 and 10, not in between 10 and 20. So in between 10 and 5. Then 5, make it one is 5 and another is 7. Then you put it in between 7 and 10 and in between 7 and 5. Then you check whether this one is in between 7 and 5 and in between 7 and 10. It is very difficult to tell these things. I mean, so narrowly. Because 10 and 5, it apparently it looks almost similar. So our acceptable limit is 5 and 15. Already have discussed. Don't worry, I'm going to give it to you. This, I mean, so from that you will be able to get these things. Now this odor, these are the chlorine, hydrogen sulfide. All these are sources of odor. We have said it should not be objectionable odor, unobjectionable. So if it H2S is there, the smell of rotten egg is also there, and also if it is a pyridine is there, then it's a very strong chemical, pungent smell is there. I had to work with that pyridine in my MTech thesis, so I know the very pungent smell. Even if whenever I used to work with that chemicals, that after returning home I couldn't take food. It creates a vomiting tendency. The smell is so pungent. So these are the odor caused by these things. The phenol is one, phenol, chlorine, what I've said, the pyridine, etc. These are the type, earthy, fishy. You can say the sweetish, I mean, odor, etc. We usually define it normally in the 10500. It is written as it should be unobjectionable. But there is a, I mean, to certain limit, we can say that there is a number for odor and taste. There is a threshold number. That means some odorous sample, along with that, if you mixed the uh, odor-free water, distilled water, as a dilution water, and divided by the that sample. Say, for example, it clearly I am saying that. So for the 1 liter, to make it to you as acceptable, with the 1 liter of sample, if you mix the 3 liters of distilled water, then if it is acceptable to you, then 1 plus 3 divided by 1, the value is 4. Then the threshold value will be 4. And then threshold number should be 1. That means the quality should be such that we should not mix, no dilution should be there to make it agreeable. It should be a desirable one. But it can go up to 3, not 4. That means 1 liter. Along with that, 2 times water you can, 2 times distilled water you can mix, dilution water you can mix, and then if it is agreeable to you, that you can accept. But this is not the standard for IS 1050. This is called as agreeable limit. Is agreeable. The pH value. These are the desirable limit, and then you know the pH is corrosion. Low pH means acidic corrosion. High pH is also very much corrosive. Don't think that it's high pH so you can put it in your skin. This is the same thing. The caustic soda. If you put it one pellet in your hand, then you will find that this one is going to corrode your hand. ফোসকা পড়ে যাবে হাতে. Same as acid. Taste. Presence of chloride, presence of sulfate. So taste is also maybe salty, sweet, sour, bitter, etc. And also this one is considered same as, this is threshold limit value, agreeable, non-agreeable, etc. Turbidity. So this is one is turbid water, this one is less turbid water, this one is more turbid water, and it is measured by the nephelometric turbidity unit due to the presence of this particulate matter. What is turbidity? The presence of colloidal or suspended particulate matter. This is a coastal area, the coastal zone. If we have taken this picture was taken from the satellite. So this is look at this turbid water river. It looks black, and then look, black means it doesn't black. It is GIS picture, so it is it's shown like this, and the sea water in the, look at that, nearby the seashore, the color is different, and the mid sea, this one is color is different. the presence of bacteria, the presence of resuspension, presence of discharge, area discharge nearby in sea to that sea coast. So all this actually, and presence of phytoplankton, zooplankton, all these things create colored minerals, etc. Along with these are definitely the dissolved solids, etc. Already I have said organic, sometimes inorganic. So these are the color causing things in the phytoplanktons, etc., nearby the shore, and the resuspension of the material, etc., and all this. What I have told, this is the create turbidity. Hmm. What is the effect of turbidity? This one is going to settle, and depth is going to shallower and shallower. And also, what are the small shelter for fishes? These things are going to be clogged by uh, uh, this turbid material or suspended material, and then these things are going to be exposed, and then the food chain will be vulnerable. That means they are easily exposed for the larger prey, and they are going to take all these things, and these things is going to finish, and then the food chain is going to break. Hmm. And also, this create damage for the sensitive gill structure because of the fish, because it as it passes through this water, it passes through the gill. Then this particulate matter is going to create problem and create the friction, and then create damage to this. And light, it create hindered the light penetration. That means the light going to cannot penetrate the deeper depth. That means that they cannot do the, I mean, in that depth plant cannot do the photosynthesis. If they cannot do the photosynthesis, they then they cannot produce the carbon dioxide, then sorry, they cannot produce the oxygen. So dissolved oxygen is also going to be limited in that case. So all these are bad effect of turbidity. This the effect of turbidity due to the presence of iron type of ore. This is nearby the iron ore. This is the color turbidity due to the presence of inorganic substances, not always the organic substances. Impact, already have told this. Maybe one small silica is in suspended form, it creates turbidity. You can say the silica is very less reactive, so this is not going to create any problem. But thing is that this can create uh, a what should I say, the uh, a host, or it can create a room for the heavy metals. Heavy metals can attach, or toxic metals can attach with on top of that. PCBs, polychlorinated biphenyls, or polycyclic aromatic hydrocarbons like benzoypyrene. All these things can be attached with this. Hmm. So that's why whenever turbid water is there, we usually do not take this. We are not going to consider this. This is only that this is silica. This is not going to create that constipation in your body. Otherwise, this is not going to create any health effects on you. No. Apart from whatever I have said, this get health effect also, because this will be the host of all these toxic materials. I'm not going to go these things in detail. So some measuring instrument is turbidity rod and Jackson turbidity meter. Please go through these things. So this is one is attenuation of light. Look at this Jackson turbidity meter. This is the old technique. They say in this one, in the ones this is the cylinder. Below this cylinder, it's a graduated cylinder. Below this cylinder, one specific type of candle we used to, so that the amount of light should be same. Specific candle we used to burn, and then from top of that we used to observe these things. When the outer shape of this flame is not clearly visible. And when we used to put water in this turbid water in this graduated glass tube, and when the this shape of this uh, the flame is not clearly visible, then that level we used to that value in the scale we used to consider, and this is the turbidity. And definitely, if the thickness is less, that means this one is thickness, the depth of this one is less. That means this one is more turbid or less turbid. Depth of the water is less, then this is a more turbid or less turbid. এই তোরা কি ঘুমোচ্ছিস নাকি রে?
না স্যার
লেস টার্বিট
লেস টার্বিড, হ্যাঁ, মারও একটা টেনে থাপ্পড়। ওটা যদি লেস টার্বিড হয় তাহলে তুই আরো বেশি করে দেখতে পাবি যে ওটার আউটার পেরিফেরি অফ দ্য ফ্লেম ক্লিয়ারলি ভিজিবল। ওটা বেশি টার্বিড বলেই তো লেস ডেপথেই তুই দেখতে পাচ্ছিস না।
স্যার উপর থেকে মাপবো না নিচ থেকে?
আরে উপর থেকে।
সূর্য আর নিচ থেকে তো ওটা রয়েছে, তুই যেটা নিচ থেকে তুই দেখতে পাচ্ছিস কি স্কেল, স্কেল নিচ থেকে। আমি তো সেই জন্য তো অত কিছু উপর থেকে মাপবো বা নিচ থেকে মাপবো তো আমি বলিনি, আমি ডেপথের কথা বলেছি। তুই একটা ওয়াটারের ডেপথ কি উপর থেকে মাপিস না নিচ থেকে মাপিস?
স্যার উপর থেকে।
বলে কি রে, আমার ডেপথ অফ ওয়াটার আমার স্কেল থেকে রয়েছে, তুই একটা স্কেল ফেলছিস, স্কেল ফেলে সেখান থেকে দেখছিস যখন, সেটা তো নিজে যে ওয়াটারের ডেপথ রয়েছে কোথায় থাকতে, বটম থেকেই তো উঠবে রে বাবা। বটম থেকে উঠবে এবং তুই সেখানে স্কেলটা ফেলবি, একটা নিচে যাবে এবং সেখানে কি হয়তো 2 এসে ঠেকলো, তাহলে 2
কম ভিজিবল হলে ওটা বেশি টার্বিড, সেই
হ্যাঁ
জন্য
বেশি
visible
টার্বিড,
হচ্ছে না।
তার মানে ডেপথটা কম, কম ভিজিবল হলে নয়, কম ডেপথে যদি ওটা ভিজিবল না হয় তার মানে বেশি টার্বিড বলেই কম ডেপথে, দিস ইজ নট এট লেস ডেপথ, at less depth it is not visible to us, at lesser depth it is not visible as because this one is very turbid, and this is called attenuation of the light. That means this is the obstruction of the light. This is the measurement technique with the help of obstruction of the light. When it obstructs the light more, that means if it is more turbid, it is going to obstruct more. So that's why we cannot we cannot see the film, that outer periphery clearly from the when we look from the top of this water. তাও আছে তো, দেখতে পাচ্ছিস না ক্যান্ডেলটা নিচে আছে, this is the position of this eye, and the difference between at the present turbidity measuring unit is not the obstruction, is the actually the scattering of light, both Bailey's turbidity meter or nephelometric turbidity meter. That means light is passed in the 90-degree direction to the sample, and whatever turbid material is there, they scattered the light, and from the 90-degree direction our detector or eye we have to place, and then we detect the turbidity with the reference one. What is the reference one? The formazine, which gives us the known turbidity. And comparing with the reference, we used to say what is this value is 1 NTU, 2 NTU, 5 NTU, 50 NTU, whatever it may be. This is the vials. This is the formazine turbidity standards. Formazine is a chemical. This one is also biodegradable. Regular basis we have to prepare and use. This is a polymer, formazine polymer we used to use. This one is going to create turbidity. If it is 400 unit, it looks like this. If it's 0 unit, a crystal clear water. 2 units, it looks like this. So with this one is the reference. And another turbidity by the suspended clay. Look at that. The color is different, but turbidity, we measure the turbidity with the help of this. Scattering of light will be the same if turbidity is same. And I mean the equalization point, this Formazin standard 50 NTU is equivalent to 50 JTU. Sorry, 40. Otherwise, Formazin and JTU is not the same. Jackson turbidity unit. NTU is the nephelometric turbidity unit. You have to remember these things. And another turbidity unit measuring the turbidity is, I mean, it could very less costly and very quickly. If you have to measure the quality of the river, turbidity quality of the river or pond, I mean the surface water, then this is the Sech disc. This disc, at the middle of the disc, one suspended rope is there. You have to dip it, and whenever you cannot distinguish this clearly, the clear border between the black and white, and then up to that depth, this one is a turbid. Definitely less depth means more turbid, deeper depth means less turbid. This one is very less costly equipment, but things that to measure the quality of the water very quickly, or for reconnaissance survey, definitely you can utilize this turbidity measuring technology. Total dissolved solids 500 and 2000 already have said, and these are the sources for the dissolved material. It creates problem of hardness, scale deposit, sediments, cloudy colored water, staining, and all these things. These are the sources of total dissolved solids. Alkalinity. I'm going to discuss this. Alkalinity means, what is the alkalinity causing ion strain? What are the things? Alkalinity ki alkalinity create kore na? Acid ki create kore? মানে what is the sources of acid? Sources of acid means মানে কোনটা অ্যাসিড ক্রিয়েট করে? মানে ক্যালসিয়াম থাকলে অ্যাসিড হয়?
না স্যার অ্যালকালি হয়।
ক্যালসিয়াম থাকলে অ্যালকালি হয়। বলেছিস ভালো। কি থাকলে অ্যাসিড হয়? কোন এলিমেন্টটা অ্যাসিড হয়?
সালফার,
মার বদলে
কার্বন ডাইঅক্সাইড,
পদ্ধতি সালফার, কার্বন ডাইঅক্সাইড। হ্যাঁ, H প্লাস।
হ্যাঁ স্যার H প্লাস।
ও হ্যাঁ H প্লাস থাকে, আর OH মাইনাস থাকলে অ্যালকালি। হ্যাঁ আমি অন্য কিছু ভাবছিলাম।
হ্যাঁ তুই ভাবছিলি সোর্স কি থাকলে পরে অ্যাসিড অ্যাসিড হওয়ার সম্ভাবনা থাকে। হ্যাঁ ঠিক আছে। সো অ্যালকালিনিটি কজিং আয়নস আর কি OH minus, then CO3.
So carbonate, bicarbonate.
Carbonate, bicarbonate. CO3 minus minus.
And HCO3 minus.
Good, very good. HCO3 minus. তো এটা হলেই তো হলো না, this is alkalinity. এটা total alkalinity মানে this acidity neutralize alkalinity and vice versa. So if alkalinity is there, then OH minus plus CO minus minus plus CO3 minus H plus. This is the total amount of alkalinity. Because that amount of H plus is going to neutralize certain amount of alkalinity. So total alkalinity is this. But the alkalinity causing ions, definitely OH plus, OH minus, CO3 minus and HCO3 minus. And these are the risk effect of alkalinity. Same. Low alkalinity means highly acidic, and then it's reverse. And whatever you have said, that CO2, if CO2 is present there, that acidity for natural water is caused due to presence of carbon dioxide. Above pH 4.5 is mainly, CO2 is mainly responsible for acidity. Or if it is pH 4.5, then mineral acidity. Say for HCl, H2SO4, like that, mineral acidity. These are the normal thing. Alkalinity is measure its capacity to neutralize the acid, etc. etc. পড়ে নিবি। ঠিক আছে, এটা দেখেও যাচ্ছি না, আমি যেগুলো বললাম ওগুলোই টোটাল অ্যালকালিনিটি বাইকার্বনেট অ্যালকাইড। যখন হার্ডনেস বলবো বলে দেবো। Hardness. What is hardness? Hardness is caused due to polyvalent metallic ions like calcium and magnesium. কি করবি, বাইরে যাবি? Polyvalent metallic ions. These polyvalent metallic ions, এটার মধ্যে কি এছাড়াও কি হতে পারে? আয়রন, স্ট্রনশিয়াম, ম্যাঙ্গানিজ, এগুলো হতে পারে, অ্যালুমিনিয়াম, all these polyvalent metallic ions. They may cause hardness, but thing is that this hardness for our environmental purpose, their contribution to the hardness is negligible. So mostly for our purpose, environmental engineering purpose, we consider that the hardness is created by calcium and magnesium only. Calcium and magnesium. And along with the calcium and magnesium to free থাকবে না, calcium and magnesium definitely along with certain carbonate, bicarbonate, chloride, sulfate, nitrate, etc. So these things are also present as a these are the cations, and the associated anions are these. Desirable limit and permissible limit. Hardness এর problem গুলো জানা আছে. These are the iron. Look at that from this picture. It is clear that if the iron amount of iron, then what is the problem? This is the iron affected state. Assam, Bihar, Chhattisgarh. That look at that presence of iron is more. That Bihar, Chhattisgarh, Odisha. এখানে দেখ, এটা mineral deposits are more. Bihar, Chhattisgarh, Odisha. এখানে iron mines are also more. আসামেও প্রচুর presence of iron is high. So এই যে পারমিসিবল লিমিট এগুলো বলেছি, এটা কিন্তু ফুল পারমিসিবল লিমিট। এটা হচ্ছে 1 at present, after on the basis of 2015, this one is 1 permissible limit, and these are the effect of iron. দেখে নিন, these are the effect of manganese. ম্যাঙ্গানিজ যদি প্রেজেন্ট থাকে মানে জল একদম কালো রঙের হয় এবং একটা বিশ্রী গন্ধ বেরোয়। আয়রনও, বিকজ অফ দ্য প্রেজেন্স অফ আয়রন ব্যাকটেরিয়া, ইফ ইট ইজ দেয়ার, এমনি কিন্তু খুব একটা এমনি এফেক্ট করে না। মানে আয়রন যদি প্রেজেন্ট থাকে বেশি জলে, প্রথম কথা উই নিড সার্টেন অ্যামাউন্ট অফ আয়রন। ইফ ইট ইজ মোর দ্যান সার্টেন পারমিসিবল লিমিট, দেন ইটস ক্রিয়েট প্রবলেম, আইদার লাক্সেটিভ এফেক্ট অর আই মিন দ্য লুজ মোশন। এটা ম্যান টু ম্যান ভ্যারি করে। আদারওয়াইজ দিস ওয়ান ইজ নট গোয়িং টু ক্রিয়েট হেলথ এফেক্ট। এ দ্বারা আমার কুকুরটাকে একটু ছেড়ে দিয়েছে। দাঁড়া দাঁড়া আসছে। So sorry re. Okay, so this is manganese. Manganese create very dark color of water. So you have to clean this manganese, amount of manganese from water, otherwise also it gives bad taste. Presence of high manganese, so you have to remove this from water. Sulfate, for what sulfate থাকলে হচ্ছে the smell of rotten eggs, hydrogen sulfides, scaly deposit, corrosion, যে laxative effect, তার কারণ এটা if it is attached with magnesia, that magnesium sulfate, তুই জানিস পেটে কনস্টিপেশন হলে লোকে ম্যাগনেসিয়াম সালফেট বা এই ধরনের জিনিস খায়, খেলে পরেই there will be laxative effect,
মিল্ক অফ ম্যাগনেসিয়াম।
মিল্ক অফ ম্যাগনেসিয়া লুজ এফেক্ট হয়ে যাবে। এই জন্য জলের মধ্যে এগুলো থাকলে পরে সেখান থেকে এটা গিয়ে দাঁড়াবে ডেফিনেটলি। আচ্ছা, দেন দিস ইজ আ nitrate. Presence of nitrate is for desirable limit and permissible limit both 45 milligram per liter. This one is definitely it is good for nitrate. The nitrate form is very less, nitrate form এ বেশি থাকে, কারণ very less means actually this is unstable, nitrate and then nitrate, really it is oxidized and it forms nitrate. This is good for nitrogen source for for plants, but thing is that this is not good for us. Why I'm saying? So the health effect is methemoglobinemia or blue baby disease in infants. If the baby is less than 3 months old, in our stomach, the the pH value is around 2. মনে রাখবি যে পেটের মধ্যে কিন্তু যেই জন্যই আমরা অনেক কিছু খাই, সেগুলো অনেক কিছুতেই থাকলে পরেও সেগুলো পুরো দিস থিংস আর অ্যাকচুয়ালি dissolved by the acid or neutralized by the acid or killed by the acid. That's why many bacteria are killed by this acid. But for infant, their stomach is not so acidic. That's why some bacteria is there. Bacteria will present in their stomach because of the higher pH value, and they readily change the nitrate to the nitrite, and this nitrite is going to attached with this hemoglobin, and because it has more affinity towards hemoglobin rather than oxygen, like carbon monoxide. Carbon monoxide carboxy hemoglobin তৈরি হয়, এখানে nitrite. This nitrite is going to attach with the hemoglobin, so hemoglobin is actually carry the oxygen, and this oxygen reaches through the cell for oxidizing the food and all these things for our living purpose. So if the oxygen is not, if it is oxygen is cannot reach to the hemoglobin, there will be a starvation of oxygen and the baby turns into blue because of the less amount of oxygen or oxygen deficiency. That's why this is called blue baby disease or methemoglobinemia. That's why this one is actually very toxic, especially for disease, especially for the babies. That's why limit is considered as 45 milligram per liter. So nitrogen basically in the different forms, these are the sources: fertilizer, wastewater treatment plant, sewage. Or first of all, organic, one compound is organic nitrogen. Organic nitrogen. What is nitrogen? Actually we discharge nitrogen. Nitrogen কার মধ্যে থাকে বলতো in our body? Fat, carbohydrate, protein.
Amino acid.
Protein is the amino. Protein, the amino acid is the actually the কি বলবো, the unit of protein. Different amino acid with the different forms, they create the different types of protein. So in the amino acid, one major compound is element is nitrogen. So nitrogen is coming from, that's why initially when the nitrogen present in the water, this is the organic nitrogen. All nitrogen present in the organic compounds. This is the organic nitrogen. And then this, then because of this bacteria, heterotrophic bacteria, this free ammonia can be expelled by the boiling after alkalization. Ammonia nitrogen is initially produced by the decomposition of nitrogenous organic matter. First, ammonia is going to produce protein in the presence of a bacteria. Name of some bacteria is there, maybe the aerobic or anaerobic condition. This bacteria is going to transform this as ammonia. So the next form is ammonia. Not that entire amount of protein. So organic nitrogen is there and some ammonia is produced. Then this ammonia, in the presence of this nitrosomonas bacteria, this bacteria is chemoautotropic bacteria. These things create nitrite first, and this nitrite further oxidize, going to create nitrate. All these, nitrite and nitrate causing bacteria are autotrophic bacteria, chemoautotropic bacteria. And the ammonia nitrogen causing bacteria is the heterotrophic bacteria. What is heterotrophic bacteria? That means carbon is their food as a organic source, and the energy source is a chemical oxidation. And autotrophic bacteria, carbon dioxide, this C, that food. The food is the carbon source is the carbon dioxide. Here, the carbon source, heterotrophic bacteria, carbon source, that means food, is the organic matter. Here, for autotrophic, chemoautotropic bacteria, autotrophic bacteria, the carbon dioxide is the organic carbon source. That means food, that organic source. The food source. And the energy source is the oxidation of this reduced organic compound, that ammonia in that case. So in that way, their ammonia generation from organic compound, look at that, from organic compound, the nitrogenous organic compound in the form of nitrogenous organic compound. From the protein, breakdown of protein is the nitrogenous organic compound. And then heterotrophic bacteria, these things converted it to ammonia. And then it is a faster reaction. And then there is no oxygen required in it. And then autotrophic bacteria, they took carbon dioxide as their food source and the energy source. They take ammonia, and then for reduction of this organic matter, oxidation of reduced organic matter is the source of this, source of their energy. And then they produce nitrite and nitrate. It's a slow process. Autotrophic process is always slow process. And then here, this nitrogen needs certain amount of oxygen. Earlier one, carbon dioxide was needed. Carbon, organic compound, carbon is required certain amount of oxygen to oxidize this thing, that is carbonaceous BOD. And this one, just listen these things. Later on, I will explain again while we explain this BOD and COD. And this nitrogenous matter, this autotrophic bacteria, when this nitrite and nitrate is going to produce, this oxygen is required to convert the nitrogen is an oxide form of nitrogenous matter like nitrite and nitrate. Initially nitrate, then nitrate. And this is a slow process, and this is called NBOD. That means oxygen requirement for nitrogen. Another is oxygen requirement for carbon. That's why two BODs are there, CBOD and NBOD. Okay, later on I'm going to discuss. So there is a four form of nitrogen. And this organic nitrogen and the ammoniacal nitrogen, summation of these two is called zilal nitrogen. This is total zilal nitrogen, organic nitrogen and ammonia nitrogen. This is a pictorial representation of these things. Total zilal nitrogen. And this, and then nitrite and nitrate are going to form. So organic nitrogen is going to reduce, and then ammonia is going to produce, and then this is going to reduce initial amount, some of nitrite is going to produce, and then ultimately nitrate is going to produce. So total nitrogen is the organic nitrogen plus ammonia nitrogen plus nitrate nitrogen plus nitrate nitrogen. And this organic nitrogen and the ammonia nitrogen is the total zilal nitrogen. So you can say total zilal nitrogen plus nitrate plus nitrates is also, you can say, the total nitrogen. These are very important. Understanding of this graph is also important. And the methemoglobinemia, why forms. Then chloride. Why the chloride is important? One importance is the presence of chloride means if it is more than that, test it, bad test. If it is Na, along with NaCl. If it is NaCl, then definitely the salty test. And if it is more amount is present for the irrigation purpose, then reverse osmosis is going to create, the water is going to come out from the body of the plant. Rather than giving water, the water is going to come out. So, but the thing is that, just remember, in our urine, huge amount of chloride is going to present. Any water source, if the chloride amount is present, so from that we can suspect that it is contaminated by the sewage. That means as it is contaminated by the sewage, that means presence of pathogenic bacteria will be more. Sources are given and all these things are given. Definitely if it is source of fertilizer, etc. But if it is a source of sewage, then domestic sewage, then there is the chances of pathogenic bacteria is more. Presence of pathogenic bacteria. Fluoride, already discussed. Arsenic, already discussed. Chromium, এগুলো দেখে নিস, স্কিন ইরিটেশন এটসেট্রা এটসেট্রা থাকে। কপার, কপার এইটা মনে রাখবি যে এখানে থাকলে পরে if it is more than the permissible, these are desirable limit and permissible limit, these are the sources and these are the effects. Anemia, digestive disturbance, liver damage, it creates liver damage, prolonged use of these things. The name of the disease is emesis, EMISIS, emesis. It creates liver damage. Cyanide, thyroid, nervous system damage. Lead, it affects child very much. Anemia, problem of central nervous system, even if IQ system, because brain nerve damage, it creates brain nerve damage, hearing problem. And sometimes the disease is called the plumbism. এই জন্য আমরা এয়ারে আনলেডেড পেট্রোল we have to use the unleaded. এখন আর lead is an anti-knocking agent, easily available. It was widely used. Later on because of the inhalation of the lead, as we were facing lots of problem. That's why now the unleaded petrol we have to use. Some other anti-knocking agent we have to use. For this is for air pollution. Or if you same thing, if you in the water, if these things are present, then it's going to create the same kind of problem, kidney, etc., neurological problems, etc. So it is a very important toxicity. Now look at this, just like same as arsenic, 0.01. Hmm. Why the disease is called plumbagism? Because in earlier in the Roman era, the top level of that high officials and etc. মানে রাজার কাছের লোক যারা আর কি, including the king and the surroundings of the kings, they have the water supply system through the lead pipe. They had this water supply system through the lead pipe, and as the lead is a very, very, I can say, moldable, soft one. It's the weight is heavy, but it's a soft one, so easily it can mold into a pipe, and the water is supplied through this lead pipe. It's fine, but after 50 years of age, first of all, their standard of living was, it's not and very good one. Good one means in that sense that taking too much of alcohol and etc. All these things were there. Apart from that, this lead was created problem. Later on, it is detected that these are the problem. These problems are created due to lead. Then use of lead for conveying this water system, conveying the water, as removed, and this disease, name of the disease, still used to call that plumbagism, lead related disease, because the plumbing, the pipeline water supply, all these things is called the plumbing. Mercury, the Minamata disease, probably you have heard, এখানে লিখেছি Minamata disease, নামটা নেই, দেখে নেবে বই থেকে. Minamata disease is created by the mercury, because mercury is create the damage nervous system, and not only that, distorted baby, that means genetically distorted baby is going to form. It creates genetic problem also in the babies. So that's why the mercury has a bioaccumulation problem. That's why the mercury is very, very toxic. In the Japan, in the Minamata Bay, it was first detected. That's why this is as per the name of the bay, it is named as Minamata disease. Lots of chloralkali industries were there. From this chloralkali, lots of hydrogen, lots of mercury was used for making the chloralkali. So that's why the mercury was discharged in the river, and the presence of mercury created that disease. That's why it is named as Minamata Bay. It is Minamata disease. These are the effects of Minamata disease. Zinc is actually create the metallic taste. Taste wise, this is bad. Otherwise, not much. It doesn't create much problem. That's why its limit is also high, permissible limit. This is a macronutrient, and the permissible, we need certain amount zinc, but it should not be more than 15 milligram per liter. Desirable limit is 5 milligram per liter. Coliform bacteria, I'm going to discuss these things. Already you know what is the limit. It should not be present any coliform bacteria. E. coliform bacteria, one is total coliform bacteria, another one is E. coli bacteria. These are the limits, already have discussed. Radioactive substances, discussed. alpha and beta particle, one is এটা ভুল দেওয়া আছে, one is 0.1, another one is 1 becquerel। আমি ওটা যেরকম আগে যেরকম দেখালাম, কনসিডার দ্যাট ওয়ান, নট দিস লিমিট, এটা পুরনো। আচ্ছা, ডিজেল ওয়াক্সিন এগুলো নিয়ে আর কিছু বলার কিছু নেই, দ্যাট দিস থিওরি লেটার অন আই এম গোইং টু ডিসকাস দিস থিংস। আমি তোদের একটা পাঠ পাঠিয়ে দেবো, তার সঙ্গে এই ইপিএস স্ট্যান্ডার্ডস গুলো দেখতে পাবি, যে সেম থিং, এটা পাঠালেই তো ওগুলো পেয়ে যাবি। তার সঙ্গে আই উইল শো ইউ দ্য ইপিএস স্ট্যান্ডার্ডস। হ্যাঁ, সেম, শুধু একটু অন্যরকম করে বলা আছে, গোল এটসেট্রা। এম এম এমসিএল, এমসিএল মিনিমাম কনসেন্ট্রেশন লেভেল, মিনিমাম কনসেন্ট্রেশন লেভেল গোল, মানে এটা আমাদের গোল, উই হ্যাভ টু অ্যাচিভ দিস, যেটা আমরা বলছি আমাদের ডিজায়ারেবল লিমিট অর অ্যাচিভেবল লিমিট, সেগুলো আই মিন দ্য অ্যাকসেপ্টেবল লিমিট, একই জিনিস, নাম চেঞ্জ। কিন্তু এখানে একটু বেশি করে দেওয়া আছে, চাইল্ডের জন্য কত, অমুক কত, তমুক কত, এসব। এই প্যাথোজেনটা পড়িয়ে শেষ করে দেবো, চিন্তা নেই, বেশি পড়ানো হয়ে যাচ্ছে মনে হচ্ছে না, কিছু করার নেই রে। দেখ কি কি থাকে, ওয়াটারবোর্ন প্যাথোজেন্স, ব্যাকটেরিয়া, দিস আর দ্য সাম অফ দ্য ব্যাকটেরিয়া, সালমোনেলা, প্যারাটাইপি, সালমোনেলা টাইপি, হোয়াট আর দ্য আই মিন ডিজিজ ফ্রম দিস বলা আছে, কমা, হ্যাঁ, ভিব্রিও কমেরা, কমা, কলেরা। Another one is virus, hepatitis, poliomyelitis. Another is protozoa, Entamoeba histolytica, amoebiasis, Amasha, সোজা কথা, Giardia, Giardiasis, then Helminthes, ওই tapeworm, etc. So these are the 1, 2, 3, 4. These are the 4 types of pathogen I have given: bacteria, virus, protozoa, helminthes. আচ্ছা, লেখাটা খুব একটা ভালো নয়, করা আছে, আমি জাস্ট বলে দিচ্ছি, খুব একটা ইয়ে করার কিছু নেই। সো ব্যাকটেরিয়া কিরকম হয়, আইদার প্যাথোজেনিক অর নন প্যাথোজেনিক। মোস্ট অফ দ্য ব্যাকটেরিয়া নন প্যাথোজেনিক ইন নেচার, মানে খুব একটা হার্মফুল নয়, হার্মলেস ব্যাকটেরিয়া, খুব একটা নয়, হার্মলেস ব্যাকটেরিয়া। সাম অফ দ্য ব্যাকটেরিয়া আর অ্যাকচুয়ালি দ্য হেল্পফুল ব্যাকটেরিয়া, there is symbiotic to the symbiotic relationship, they help us. And pathogenic bacteria means which causes disease. Parasitic association is there, so it causes disease. Human health, human death, etc., etc. Plant, animal, নাম, রোগগুলোর নাম দেওয়া আছে। You cannot avoid bacteria or virus. Why? Because in 1 gram of human feces, 10 billion bacteria is going to present. It's going to present. And in 1 gram of soil, it's 1/10 of bacteria, millions. In 10 millions, it is going to, not 1/10, it's 10 millions is going to present. On thousands, or hundreds, millions, it's going to present. So it is always there. It is always, everywhere it is there, everywhere it is there. Bacteria free world, this is not possible. Acha. Now, coliform bacteria. total coliform bacteria. Few of them are non-fecal and some of them are fecal. Or rather, I should say most of them are non-fecal, some of them are fecal. What is fecal? Fecal means which we used to find it the intestinal tract of the warm-blooded animal. Amra warm-blooded animal. We, pig, horse, dog, all of us is a warm-blooded animal. So আমাদের intestine, in our intestine, whatever bacteria is going to stay. This is called fecal bacteria. Fecal bacteria is going to stay. Not that whatever bacteria, fecal bacteria is going to stay. And whatever other fecal bacteria is going to stay in the nature, in the soil, in the plants, etc. These are the non-fecal bacteria. Because the environment is different. Environment in our intestinal tract, we use the bile secretion is there. This thing kills bacteria. The pH value is less, that kills the bacteria. The temperature is high, 30 more than 35 degrees centigrade. All these things kills other bacteria. Whichever is going to survive there, fecal bacteria, these things are the fecal bacteria. Others bacteria are the non-fecal bacteria, soil, decaying vegetations, etc. These things are present. And most of them, except few certain strain, are the pathogenic in nature. Otherwise, few of them, sorry, ulto bollam bodhoi, very few of them are pathogenic in nature. More than 99%, more 99.99% is the non-pathogenic. That means non-hazardous in nature. আর আমাদের বডিতেই তো রয়েছে, হ্যাজার্ড ক্রিয়েট করছে না, they are helping us with the symbiotic relationship. 96% of the coliform present in the human feces are exclusively found in the feces only. That's why, and look at that, it is incubated in the 35 degrees centigrade, which I have told, and in the bile. So coliform bacteria is a rod-shaped anaerobic facultative, anaerobic and facultative bacteria, aerobic and facultative bacteria, and all these things, the gram-positive, gram-negative, etc. This is I mean, the characteristics of the bacteria or identification of the bacteria. I'm trying to tell you the what is its importance. Abundant in nature. The feces of the abundant in the feces of the warm-blooded animal, the fecal coliform. And whatever present in the human feces and all these things, 96% of the coliform present in the human feces, which are, these things are exclusively found in that place only. That's why if this fecal coliform, that means which are present in the intestine of the warm-blooded animal, if these things are present in that, we can say that the source of this fecal coliform is the night soil or excreta of the warm-blooded animal. That means chances of presence of pathogenic bacteria is almost certain. But itself, this coliform bacteria is not pathogenic bacteria. So the আমার কি হাজার একটা প্যাথোজেনিক ব্যাকটেরিয়া খুঁজে তারপরে আমি বের করে জলটাকে বলবো যে thousands of pathogenic bacteria, I have to do the thousands of tests. Someone do that paratyphoid test, okay, it's not present. Then okay, then have you done the paratyphoid test? Paratyphoid also may present. I mean, thousands of this kind of pathogenic bacteria is there. So that in that case, thousands of pathogenic bacterial tests are there, and maybe the only one bacteria is present there. That may multiply and create problem after a few days. So number of is also less. So rather than doing all that to overcome all this difficulty, my intention is to tell that whether this one is good for us or bad for us, whether pathogenic bacteria, chances of pathogenic bacteria is there or not. Just test whether there is fecal coliform is there. That means if it is yes, then the presence of pathogenic bacteria is there. So discard it or treat it, disinfect it, and then use it. That's why this one is used as an indicator. Ekhane bola ache. So many thousands of pathogenic bacteria. If you have to test this thing, it is a time-consuming and laborious analysis. Many types of analysis is required, and these things present in low concentration. So sample volume and all these things it may not present whatever sample you have taken. It may present in the other portion of the water, and the high cost will be there. Alternatively, you can use this non-pathogenic one to indicate, to find out this pathogenic bacteria. এই যে খুব মানে রেয়ার স্ট্রেন গুলো হচ্ছে প্যাথোজেনিক, একটা স্ট্রেনের কথা এটা বলা আছে, this strain is pathogenic bacteria. That's why, because of this reason, it's present in the intestinal tract of the warm-blooded animal, found in much higher concentration. It is non-pathogenic in nature, is easily detectable, relatively fast and inexpensive analysis. So because of all these things, we use this coliform bacteria as an indicator of the pathogenic bacteria. Though I know you cannot say that its presence is not an absolute indicator. এমন হতে পারে শুধু কলিফর্মই আছে, অন্য কোনো ব্যাকটেরিয়া নেই, হতেও তো পারে 1 কোটির মধ্যে একটা কেস। কি দরকার আমার ওই চান্স নিয়ে? But we can really, from the all practical purpose, we can say that okay, it is pathogenic bacteria is present in it. So we discard it and we can treat it. ঠিক আছে, ছেড়ে দিলাম। 15 মিনিট এক্সেস নিয়েছি 2 ঘন্টা থেকে। আবার সামনের শুক্রবার ক্লাস হবে। কতজন পড়ে আছে? 17 জন। খারাপ নয়
স্যার। বলছিলাম যে এটা
বল, কোনো কোশ্চেন থাকলে বল
স্যার। এইটার পিডিএফটা কি পাওয়া যাবে?
আমি দুটোই যা পড়েছি সবকটা পাঠিয়ে দেবো,
ওকে স্যার।
পুরোটাই পাঠিয়ে দেবো।
স্যার কলিফর্ম ব্যাকটেরিয়া এই এমপিএন টেস্টের কোনো অঙ্ক হয়?
হ্যাঁ, অঙ্ক তো হয়। করবি?
না
এই সঙ্গে সঙ্গে না।
স্যার পরের দিন করে দেবো।
আচ্ছা ঠিক
আরে
আছে।
ছাড় না।
আচ্ছা ঠিক আছে, শোন, ওটা ওয়েস্ট ওয়াটারে করে দেবো, ওয়াটারে করাবো না। ওয়েস্ট ওয়াটারও তো আমি এটা পড়াবো আশা করছি তোদের। ওটা তখন ওই অঙ্কটা তখন করিয়ে দেবো ওয়েস্ট ওয়াটারে, ঠিক আছে? এখানে আর চাপ দিচ্ছি না, কারণ আমার সময় কম। কারণ আমাকে তোকে হার্ডনেসের অঙ্ক করাতে হবে, তা না তুই নাম্বার পাবি না। হ্যাঁ, আমাকে তোকে অ্যালকাইনিটির অঙ্ক করাতে হবে, নাম্বার পাবি না, তা নাহলে নাম্বার পাবি না। তারপর সোজা সোজা কিছু টেস্ট করাতে হবে। বাবা, ভাগ্যে রাইট টাইমে শেষ করেছি। আন্দোলন হচ্ছে চারিদিকে, আমি শুনতে পাচ্ছি না কোনো কথা। ওকে, গুড নাইট।
ওকে স্যার,
হ্যাঁ,
গুড নাইট।
গুড নাইট। আমি ক্লাসে আপলোড করে দিচ্ছি। হ্যাঁ,
স্যার।
ক্লাসরুম। ওকে।